Hello and welcome to 6.2 Notes. So in section 6.1 we reviewed proportions, and in 6.2 we're going to be applying the use of proportions to solve similarity problems. Okay, so this lecture is largely an applications lecture, so that means there will be absolutely no postulates or theorems to write down, so I think these notes might be a little bit shorter for you. And again, this is largely an applications lecture, so let's just start right now with this problem. In the diagram, Mn divided by Rs is the same as or equals Np divided by St, and we need to solve for this missing length St. Okay, so you start off by writing down the given proportion and then just filling in what you know. Okay, and by looking at the diagram, I can see that Mn has a value of 8. Okay, so Mn is 8, and again by looking at the diagram, Rs is 10, Np is 4, and St is x. We don't know what St is. That's our job to find that out. Once you have the proportion written down, then you cross multiply to solve for x, and you get that 8x is equal to 4 times 10, which is 40. So 8x is equal to 40, and then you divide both sides by 8, and you get x is equal to 5. So our missing length St is 5. Okay? Moving right along, we have in this problem, in this diagram, we have BD divided by DA is equal to BE divided by EC. And here are the values in blue. Okay? And the way you solve for this missing length, or this value x, is again by filling in values into the given proportion. But now if we look at BD, we need to find out what BD is. BD is just this length from here to here, and we don't necessarily know that, or it's not explicitly given in the diagram. Okay, we know that the whole length, this whole length is x, and we know that this part is 3. So how long is just BD? Well, it must be x minus 3, right? It's this whole length, which is x, take away this little part, which is 3. And that would give you the rest of the BD, right? Give you the other part of that line segment. So it's x minus 3. Okay? So BD is x minus 3, and DA is given as 3, and BE is 18. I'm just seeing right there from the diagram, and EC is 6. So there's my proportion right there. I can go ahead and cross multiply if I want to, but I'm noticing that 18 divided by 6 is 3, right? Or 3 over 1. So I'm going to just reduce that ratio right now and get x minus 3 over 3 is equal to 3 over 1. And then at this point I can cross multiply. You don't have to do that step, but it was just again that I noticed that 18 over 6 is the same as 3 over 1, and so I thought I would just reduce that. You don't have to. You can cross multiply at this point if you want to, and you'll still get the same answer. I just thought it might be easier to work with more simple numbers, right? Okay, so cross multiplying, you get x minus 3 is equal to 3 times 3, which is 9. And then you add 3 to both sides, and you get x is equal to 12. So line segment AB, this whole line segment, is equal to 12. And if you wanted to know how long BD was, just this shorter line segment, then BD is equal to AB minus AD, right? The whole line segment minus the smaller portion. And AB, we already figured out, is 12, and AD is 3, so BD must be 9. Okay? Okay, and moving right along, what happens if we have the same diagram, but now we know that, or we're given rather, that DE over AC is equal to BE over BC, and it's our job to find AC, to find the measure, to find this length. Okay? So I'm going to call that Y, use a different variable so as to not to confuse it with that, right? You don't want to use the same variable for different entities or different things within the same problem. So I'm going to label AC as y, and but it's the same methodology. Okay, you still write down the given proportion, and then you fill in what you know. So DE is 12, AC is my y, BE is 18, and BE is 18, and BC is equal to 24 because BC is this whole entire length, and that equals 18 plus 6, which is my 24. Okay, so I have all those values that I got from the diagram, and then at this point you can cross multiply and get that 18y is equal to 12 times 24, or 18y is equal to 288. 12 times 24 is 288. And then divide both sides by 18 and get y is equal to 16. So AC is equal to 16. Okay? And the last problem we have for today is the scale of a map is 1 inch to 24 miles. So that means that 1 inch on a map equals 24 miles in actual distance, like on the on the real Earth, on the real planet. It's 24 miles. So the cities are 4 inches apart on the map. In miles, how far apart are the two cities in real life? So what I like to do when I have a problem like this is I like to create this grid. It kind of keeps me in order, so I know I'm not going to make any mistakes, right? So everything here has to do with the map, and it's going to be in inches. And everything here is going to be in actual miles. Okay? Everything in this column is going to be regarding my scale, and everything here is going to be regarding my distances, either measured distances or actual distances, right? So plugging in values that we know in regards to the scale, we have that 1 inch is 24 miles, or 1 inch to 24 miles is my scale. And then in terms of my distances, I have 4 inches on the map, and I want to know what is my actual distance in real life. And I'm using D for distance. And if you notice, we have inches to miles is to inches to miles. So my D is going to be in miles. My distance is going to come out in miles if I use this proportion. Okay, so I have this proportion, and I got it from using this. It kept me straight, right? This grid kept me straight, so I know I'm not going to make any mistakes, right? So that's how I come up with this proportion. And I have 1 to 24 is equal to 4 over D. Once you have the proportion, then you just cross multiply and get D is equal to 24 times 4, or D is equal to 96. So the actual distance between the two cities in real life is 96 miles. Okay, so that's how you would use proportions to solve similarity problems, and of course a map is a similarity problem, right? The map is similar to what's happening in real life, but of course it's scaled down to something that's extremely manageable. That's why maps are useful, because we can open them up, unfold them, and we have a scale drawing of a real representation of the distance between, like here in Disneyland, for example. Between here and Disneyland is something like 600 miles, I think. I'm not quite sure, but I think it's along the order of 600 miles. Obviously, we can't have a real map that's 600 miles long. That would be unwieldy. But if we had a map where, say, 600 miles, equaled, or 100 miles equals an inch or something, then it would just be about 6 inches, right, to get down from here to Disneyland. So a map is also basically a similarity problem, right? So that's how you use proportions to solve similarity problems. If you have any questions or concerns, just contact me at any time, and I would love to give you a private tutoring session or help you out in any way that I can. Okay? Thank you. Bye-bye.